So you're going to have a look at this Revox tuner. It's the model B160. Revox are probably more famously known for their reel-to-reel machines, like the infamous A77 and B77 models, and their models before that, which was the G36, which I actually owned one of those when I was a teenager. Not so famous for their other gear. They make other stuff as well. They made well, the name Studer Revox was probably more known for the Studer gear, was more sort of like studio equipment, various things, really, mixers, that sort of thing. I picked this up non-working, good price. This was the lower end of the Revox tuner market, and even this would have been a very expensive tuner in its day. Got an excellent reputation for sound quality, sensitivity and basic build quality. This one's sold as I say for well, I don't know if I did say, but spares or repair, non-working. Basically the seller tells me that when he powers it up, this right hand display here comes up, but the left hand display, which I believe to be a fluorescent display, is totally blank. Now, he initially said that the left hand display was flashing and then stopped working altogether, and the tuner stopped working altogether. So there's a number of things it could possibly be. It could be the DC to DC converter that takes the low voltage and boosts it up to produce the high voltage for the fluorescent display. If it has got a fluorescent display, it could be that's gone short. It could be a power supply problem. It could be a processor problem. It could be, you know, a non-viable repair, basically, if it's something too complicated. But I thought it's worth a chance. We'd make a lovely tuner, and I'd have it at home if I get this working. So the first thing to do is to switch it on and see if it displays the 40 tones the seller was saying. Plugged in at the wall, so it's turned on. Sure enough, we get a display here in the window showing we're on wide selectivity, and it's tuned to something, but we don't know what it is because there's nothing on the left hand display. So yep, there's clearly got a fault with it. Let's pop the top off it, have a quick look inside and see if we can find anything that could be obvious. Okay, here's the inside. We've got all the tuning section on the right hand side. Looks like a load of I imagine they're IF transformers, I'm not sure, but a ton of transformers and cores in here. There's a lot going on in this thing. You can see these blue looks like crystals, also traps, you know, filter traps. Looks like there's the AM section possibly down there. There's more stuff going on here. I need to get unfortunately, the schematic for it, and I've got the schematic, but I haven't. The service manual's in German, which is going to be a bit of a problem. So the first thing we need to do is have a look over in this power supply section, just to see if we can see anything obviously cooking up or anything. And looking for even bulging capacitors and things like that. But they should have all very good quality parts in here. Nothing obviously. No, what's that under there? That resistor down there looks a bit cooked up, maybe. Could be possibly something going on there. Interesting the way that transformer's wound. It's like I've got an overwinding on it, sort of over the top of the transformer. It's like it's been put in extra. And we've got some fuse protection here, and this looks like this is all the audio stage, the preamplifier outputs. Not sure what all this is all about. Looks like a bit of a jerry bodge going on here. Someone's put some sort of idea of someone's audio upgrade. Put in some Weimer 2.2 electric polyesters in series. Looks like one of my bodges. Don't know what that is. Could be compensation for oh, come on, de-emphasis. These caps look a bit bodged into me. Not sure if they're standard, but we'll have a look underneath at the moment. That's not likely to be the problem. The problem's more likely going to be something up around here. I'm just wondering, this thing's been recapped at some point, but these capacitors look genuine, so I don't think there's anything happening there. Just wondering if the bottom of these capacitors have been cut out, but No, I think I'm imagining it, but it just looks like the bottom of that capacitor. You see, it's got like a cut around it. So I think what I'll do is I'll check the fuses first, see if the fuses are okay, and then maybe try and download it or get the schematic out. I think I've got the schematic here somewhere, so we can try and work out where we can measure the rails. I might also disconnect this board, so we're not. If there's any short on this board, it should recover this display back again. So let's have a look, see what we get. And you see this second fuse in, and there's 3 amp fuse. No, 1 amp fuse, sorry, that's blown. Doesn't look, it hasn't actually gone black, but it's clearly blown. It's open circuit with a tester. So what I'll probably do is I'll pop another 1 amp fuse in there, and we'll try again. There's the fuse. You can see usually if there's a big catastrophic failure, they go black. But at the moment, that looks okay. So let's pop another fuse in and just see what happens. And now these fuses can, believe it or not, with age, deteriorate. If they're close to this, the surge is enough to get close to their maximum rating, they can weaken and sort of eventually just blow. I'm not sure that's the problem. He did say it was flickering before it failed, so it's probably something drawing excess current, but at least we can get an idea of what's going on. Right, I'll put a new fuse in. I haven't got a 1 amp, I've got 1.6 in there, so I need to. I check the current. The current seems to be sort of okay. It's not drawing a lot of current at the moment. Let's switch it on and I'll show you what it does. And you see that the display is working now, and the right hand display is working, but that's with this cable disconnected. If I connect up the main sort of board to the rest of the unit, the display doesn't come on. So something is drawing excessive current on this rail, on this board, or the power supply is sagging. So the next thing to do is to try and have a look to work out which rail's being pulled down and try and ascertain what's going on. So what I'll do is I'll set the camera up and I'll just show you what I'm going to do. I've got these TO220 devices at the back here, obviously linear regulators or something. I'm going to go through each one of those with the connected, disconnected, and I'll just read out what I get. I don't think I can get the meter in frame. I might be able to. Let's have a go. It's really difficult to get meters in the frame whilst you're trying to do a test. Let's try and get it somewhere where you can just about see it. Can you see that? Yeah. That's the best I'm going to get, I think. Right, let's try and set this up so you can see what's going on. I could prop it up with something maybe. There you go, good. Alright, so it's in standby at the moment, so let's just check on the top of these TO220s. So there's your 5 volts. You've got a minus 26 volts there. Yeah, it says 1.3 there. On this other device is nothing on it. Okay, now we're assuming that they're the outputs. I need to confirm that once I've downloaded the manual. Right, I'm enabling the power now. And obviously the other board's disconnected. So 5.11, which checks good. Minus 26.09, so now we've got 15 on this third device. On this other fourth device, 37 volts. Okay, so I assume that's regulating at 37 volts. Actually, that might be a negative regulator. Okay, so that might be the 37 coming in. I'm not sure where the test point will be for that. We'll have to check that in the manual. But clearly got supply there. So let's reconnect the board and just quickly whiz through. I don't want to keep it on too long because we might be drawing excessive current. 5.2, minus 7.9. Okay, let's disconnect that. So we're drawing too much current on that 27 volt supply. We're either drawing too much current or the power supply isn't up to delivering the current that the board actually needs. So the next step will be to work out what that 27 volt supply actually feeds on this second board, and hopefully track it down to where the problem is. But it's obviously somewhere on this board. As soon as I disconnect this ribbon cable, we get our supply back again. So I'll download the manual and we'll have a look through. Okay, what I've ascertained is we've got a short on the, looks like the minus 15 volt rail. This capacitor here is the minus 15 volt final smoothing capacitor after the regulation point. I've got my continuity tester across there. If I connect this board back up, it's not very easy to see, we get 0 ohms across the output. So that's the capacitor in question. Now I'm going to show you on the screen. So yep, that's the capacitor on the board here. You can see it's where are we? C10, just here. So it's this point here. This is the capacitor. Once it's drawn the picture. So we've got C10. There's a short on that, but it's only when we connect the motherboard, the main board up. And if we look here on the circuit, C10. Let me just show you. Just here, C10, and it goes off and off into the main board. So the next point is to check the minus 15 volt supply on the or where the minus 15 volt supply goes to the on the board. And there's a there's a 0 ohm short, so I'd be suspicious of like an over voltage protection Zener or a back EMF diode or something that that's across the output. It's gone short or something. So, or it could even be electrolytic, but I'm looking more of a diode actually. This sort of fault sort of screams diode to me. Could be wrong, could be a transistor, could be something simple like that. But we need to move on to the next circuit. Right, it looks like the short can only be caused by 2 components on that board. This is the RF section of the board, and this is the where the minus 15 comes in. We've got this capacitor here and this ceramic here, so we've got an electrolytic and a ceramic, and the rest of it is fed off to these transistors via high resistance resistors. So this is a short on the board. The most likely culprit, I would say, is this electrolytic, and this electrolytic, I can find this on the board, I'll show you that in a moment. And the other one is a ceramic capacitor, which is extremely unlikely to fail. So let me show you that capacitor. Okay, the capacitor we're talking about is this electrolytic here, and you see the ceramic in front of it. Now you measure across there, we've got a dead short circuit, so that's going to be the area I'm first interested in. I think, as I'm going to probably have to take this board out, I'm going to do a quick trick and break this capacitor out, this electrolytic, just pull it off the board. So I'll remove that quickly, and then I'll do a continuity check again just to see if that's fixed the problem. Right, remove the capacitor, just broken it out of the board. Now this is the ceramic capacitor, so we're going to measure across here. So before we had 0 ohms. Oh yeah, that's cleared the short, so we've got a K now. So that's where the capacitor was, which is basically in parallel with that ceramic. The ceramic's taking care of the high frequency noise, and the electrolytic will be sort of like the smoothing capacitor. So we cleared that short. So the next thing to do is, I think I'll tack a electrolytic in there for the time being, with the right value, and then I can take this board out and replace it properly at a later stage if it's working. Okay, I've connected up the power supply again, and without the capacitor in. We've got display up, and everything looks normal. So the thing to do now is just I'm going to plug in an audio lead to the amplifier and see if we've got any sound. Right, it's clearly working, but what it's not doing is we've got no audio amplifier. By the sounds, the amplifier's packed up. I'm not surprised with all that old crap going on there. That's all part of the amplifier. I need to check the supply voltages to there, but I can show you it's sort of the front end's working, because if I search, it stops on known channels. You come down, it will stop on these are the various radio 1 repeaters. There's 98.8, so main one, all the way, it will go down all the way through. So it's stopping at known frequencies. So I'm pretty sure that that's working, and also the stereo light comes on, as you see there, so the multiplexer and all that side of it's working. So we just need to find where our audio is being lost. Now with all this old modification or whatever this bodge of a bloody thing is here, I need to try and track back maybe with the scope just to see where the audio is getting lost. It could be that one of the op amps, there's a couple of op amps down here that could have been fried. I see he's got one in a socket here now. Whoever's worked on this has obviously sort of been messing around with sort of the audio stage to try and make it sound better or whatever reason. So we need to track down what's going on here and have a look at the schematic. Okay, these do indeed look like audio decoupling capacitors. Rather awful modification. Now I've got the scope connected to those points there, and I'm tuned to radio 4, and you can see on the scope we've got modulation on the on audio output, so clearly working. So what I'm going to do now is I'm going to take this apart, take this board out. I'm going to fit some capacitors in here that don't look so dreadful. Probably what I also want to do is, it looks like possibly this op amp's blown up. I think this is the op amp for the audio stage, though I'm not entirely sure. The manual I've got is for an earlier version board, and these chips here, you see these pins here that are unoccupied on this board, they're occupied on the earlier version. So it's obviously an later build of a unit. So let's get those caps out, just see what he's done underneath, and see if there's anything obviously wrong, but I think it's probably this op amp's blown up. And the nightmare grows. Well, he's been underneath here and added these 0.47 Weimer capacitors. At least they actually bloody right size, you know. Now, I don't know if this has been used abroad or something, and the owner was trying to compensate for the equalization. I'm not sure, but maybe it's just a de-emphasis mod or something. Here's where he's put the capacitors in and made a bloody pig's ear of this. So I've had to rip all that lot out and try and make that a bit more respectable. It's something being spilt in here as well. It does look like that op amp, which is underneath all this crud here, is probably going to be the problem. So I just need to check the soldering, which you can see here isn't that great. The light's not brilliant. Some light so you can see what's going on. Underneath these wearer capacitors is where that chip is, and you can see, even though there's no solder bridge or anything, it could do with a bit of cleaning up. So let's try and straighten some of this crud out here. It'd be interesting to get the photograph of this and try and work out what the hell's going on, what's actually this is meant to be. I wonder if it's someone who's read something on the internet that if you change these 4 capacitors and put 2 bloody great wearer capacitors in, you get super ultra high fidelity, and it gives you DAB radio performance and works wonders, and you know, you can pick up Mars and all that sort of thing that people believe. Some people believe anyway. If you modifications online, you see some of the modifications that used to be done on audio stuff. It was quite comical. Anyway, let's rip this junk out and let's try and sort out what's going on. That's a bit tidier, isn't it? What these capacitors are, there were some 2 0.47s in parallel with each other. So they had a total of 4 capacitors, and these capacitors actually, funny enough, across the plus and minus 15 volt rail that we've just been clearing the short out of from the other board. So what I've done is I put a 1 microfarad across it and ditched the other 4 capacitors, tidied it all up and the wiring up a bit. The wire that I thought the capacitor was shorting together it was actually another wire, so it wasn't the wire I thought it was from the other end of the capacitor. It was actually a link that someone put in. I was going to say I was a bit confused with it. I thought surely that can't work because it would just short out, but so that's what that was. So this is what we've done. We've replaced these 2 capacitors. So now we've only got the 2 capacitors here. We've tidied up the top end. We've removed those stupid 4.7 microfarads. And funny enough, I mean, this is an audio bypass circuit. Why has someone put 4.7 microfarads and then put 100 picofarads in series with it, in parallel with it? I mean, what's the point in that? So, unless I'm missing the point there somewhere. Anyway, for the time being, I put a 1 microfarad polyester in there. That's the highest value I've got at the moment. The audio is not working. As we know, there's a problem with the audio is getting to these capacitors, then it comes into this op amp here. I think this is an op amp. Numbers are not very clear. But there's also this muting relay, which also might be an issue, and the muting relay might not be being controlled or turned off from a command from the. I imagine either the muting circuit on the RF board, maybe from the I don't know, the discriminator or something like that. But it's certainly not. It can't get any audio through it, so we need to investigate why we've got no audio. It also could be a muting relay that shuts the audio off when the power supply is initially turned. Well, is turned off, so it shorts the relay out and shorts the audio output out. And when you turn the power on, once the power supply is settled, it releases the relays to stop any sort of DC getting through to the input of the amplifier. So we're at this stage now. I think what I've got to do is I've got to try and download a pin out of this op amp, if it is an op amp, this thing here. I'll give you the number so you can see it, and I'll look this up. You can just see that. So it's an OPA 260 4AP. So I think that's an op amp. I'm imagining it's a stereo op amp. Find the pin out of that. See if there's an output from the op amp. If there is an output from the op amp, then it's more than likely this relay is not releasing. Done a few further checks. So yeah, these are the suppliers. The unit's powered now. I've got plus or minus 15 on these capacitors, so this is I don't know if this is an aftermarket modification, these two caps, but I hope they are. They were badly put in. Certainly these things were. So this is the audio line that comes up to the op amp. This is the op amplifier behind these capacitors here, this amplifier here, and that drives obviously the output of the op amps are fed into this relay, or across this relay, and this relay, as I thought, was just a relay that sits in parallel with the output and mutes the output when probably when the power is off. Now the op amp's working. I've checked the input and the output. I've got a nice strong audio signal there, so that's working well. The problem is the relay's not releasing, so that's a logic problem coming back from possibly, as I say previously, this board here. So I need to track this problem back, check that the chip that does this relay has actually got its supply. It could be something similar, something simple like that, or it could be a chip's popped or something like that. So I'm going to go back now and try and download a circuit diagram for this particular builder board, because this board is different to the one I've got, and we'll see if I can find out why this relay is not releasing. Let's try a little experiment. This is the level shifter thing that changes the state of the relay. And for some reason pin 14 should be high when we've got output enabled. We're not getting output high on that pin. So the relay is shorted, so it's shunted the output. So what I'm going to do, I'm going to put a 1k resistor across the VCC, which is pin 5, which is 5 volt. Pin 18, which is 5 volt, and shunt it to pin 14. That should, in theory, turn the relay on via the transistor.
With surprising new research into the best way to take.
So we've got audio.
Iron deficiency.
The next question is, why is that relay not releasing the latch?
Problem, particularly in teenage girls and women.
Clearly working.
Bleeding depletes iron stores.
So the tuner's working, isn't it? Apart from that problem there, and that problem obviously is a bit more complicated than the initial problems with all these crappy capacitors everywhere. But that's excellent, because it does mean that the tuner's working. And the worst comes to worst, I can actually bypass that if I can't find the fault. So I'm going to go back. As I say, the manual's wrong. It doesn't even show the circuit for this particular board in this model 160. It's only showing it from the 260 model. So I need to try and find the right manual, which is difficult because that one's all in Dutch anyway. So I'm only interested in the schematics, but we'll have a look and I'll come back. I've got the FM board out to change these capacitor. This capacitor that's that failed short circuit. So the one I broke off the board to get the power supply clear of the short. And surprise, surprise, when you turn it over, there's more of these bloody capacitors strung everywhere. Now, maybe these are a Revox modification, but certainly those bigger 4.7s weren't. And you can see one of these capacitors is actually across this point here, which is just here. And if you look at on the layout of the board, I'm not on the right page at the moment. Unfortunately, the manual's not exactly correct, but there is supposed to be a capacitor here. So someone's been messing around with this. I mean, this capacitor's been removed and put underneath. Why? Why would you do that? Why would you take the capacitor from the top? Now, the only thing I can think of is, in the manual it says 4.7 microfarad, or is it 47 microfarad? I will check. But someone's fitted these 100 microfarad capacitors here. Now, I think that they fit the 100 microfarad capacitors in and realised they won't fit on the board at the top, so they've stuck them on the underside. So what I'm going to do is I'm going to replace the two 47 microfarads as it says in the manual. Someone's a bit capacitor obsessive, I think, really. They seem to think more capacitance you add to the tuner, the better it will sound or something, I don't know. So let's get those capacitors reinstated in the correct positions. Clean up all this junk. I'm going to leave these. I'll leave the ceramics in there. They're not doing any harm. The ceramics, the polyesters in situ, they're not doing any harm. But it's ridiculous. They put them all over the place. There's obviously different supply rails. Unless there was a problem with the tuner, maybe it was picking up a lot of noise. Maybe it's a mod that one of the test houses do. You know, one of the repair houses do. There was an issue with RF noise or switching mode noise from the power supply, even though it's a linear power supply, so it wouldn't be that. Maybe just adding decoupling just to reduce noise from power supply, I don't know, or noise from the microprocessor getting through. Maybe this is all to aid that. But I'm going to ditch this electrolytic, tidy up the board at the top, and we'll make it look a little bit less of a dog's dinner. You can see here, but this is where the two capacitors are. See, 240 and 241. They're supposed to be 22 microfarad at 25 volt, and that's their position there. What I've done is I removed that electrolytic on the underneath, and I've removed the polyesters across them as well. I'm just going to pop in a couple of good quality 22 mic caps, or maybe 47. That would be fine. And let's get this thing boxed up. This point here is where the aerial connection fits in. I don't know if you can see that bad joint there. It's obviously pretty crummy connection, and it's broken off the board. So what I'm going to do is I'm going to reflow that joint, and what I'm going to do is remove some of the solder resist. This is the solder resist here. This is the sort of like the coating that's put onto the board to prevent the solder from taking. So you scrape some of that away, back to the joint. And I'm going to reflow the joint. So all that is the aerial input lead. I just want to make sure that's got a better connection. And then what I'll do is I'll glue the top of the connector to make sure that that stays in place. This has obviously had some work done it. You can see a bit of rework done here along this part of the board here. I'll have to have a look to see what that is on the other side. It looks like part of the RF front end. So just reflow along there and track it along slightly. Hopefully get it to flow. Sometimes it takes a bit of job to get it to flow. I'm going to have to remove a bit more of the solder resist. But the idea is to give it a bit of a bigger footprint, so it gives it a bit more strength and less likely to fail again. Shouldn't be using this. Is my trimmer tool. Cut back a bit more of the solder resist. See if we can get it to flow across to the pad. Or you could also put a link in there. You could wrap a piece of wire around and make a link across. There we go. So we've got a flow now to that track. So the connection's a bit more reliable, hopefully. Okay, so that's let's get this board back in, and we'll investigate the problem with the muting relay, but I think I might have sussed out what that is. Here's another interesting thing that's happened to this tuner. Obviously, I don't know, it's obviously an amateur who's worked on this thing. When this is the screen, the RF screen that protects all the RF section. I'm just putting it back in after repairing the power supply section, you know, where these capacitors were missing. And I sort of soldering it down, and I saw these two wires here sticking through, and I thought, oh, that must be a ground connection, you know, to ground the shield to the circuit board. And I'm thinking, yeah, it must be that, screwing it back together. And I think, I want to check that. Take it apart. Look what's underneath. It's a bloody capacitor that's been crushed down, and you can see it's been crushed down, and you can see the legs have all squashed. So that would have stopped it from working anyway. So even though the seller said it worked briefly, I really don't believe him, because he said it worked briefly and he knew nothing about the capacitors inside or anything modified. So I think he's been in here, bodged about, buggered it up and thought, oh, sod it, I don't know what's wrong with it, I'm going to sell it. Because he did actually say he does work in electronics, but it was a bit above him. So yeah, bit suspicious. Anyway, I took in great pleasure in saying it was almost working, and I got got sound out of it, which he was looked a bit miffed, sounded a bit miffed about. But if he'd paid a bit more attention to detail, maybe he would have spotted that things like the capacitors were trapped under metal plates and things, and sort of just the general bodging he'd done on the board would have possibly if he just left it alone and used it as a tuner, it would have been fine. So anyway, let's get this back in, get the plate back in, and then we'll investigate this relay. Okay, so that's fixed all the power supply section. That should be okay now. Leaves us with two remaining problems. One is that when I select mono, the tuner doesn't actually go into mono, even though it shows the mono annotation on the LCD display down here. The signal is clearly stereo, and it's not switching, and that's some sort of microprocessor problem. The other one was that if I don't bypass this chip here and enable the relay manually, I don't get any audio because the muting relay stays muted. So what I did was I went through and checked all the fuses again and found this fuse here, which is basically all this does is like what we would call at work a built-in test equipment. Basically what it's doing is it's looking for a correct voltage on the input supply. This is basically a circuit that runs through these couple of transistors down here, these two transistors here, and it's rectified for a couple of diodes down here, these two diodes. So basically we've got AC, rectified AC, it's smoothened, and these transistors look at the level, and if the level's correct, then it sends a signal to the DAC, or this chip here, saying supply level's good, release the relay. So now what happens when you switch it on, now the fuse is good. If I turn it on, just make sure everything's ready to go, nothing's shorting out. It'd be a shame to kill it now I've got it ready and up and running. You'll hear the relay turn on. Ready? There's the click of the relay. And now when I connect a stereo, an aerial up to it, when I press the mono button, I actually lose the stereo signal. So that's working. So that's all that was. The mains detection circuitry obviously runs more than just the relay muting. It does other things as well. So good. Let's get an aerial on it, get the back on it, and see what it sounds like. Okay, so let's see what it sounds like then. We'll go for obviously copyright protection, things like that. So we'll select tuning mode. Next station up. That's a very weak signal. You can't really see the display from here, unfortunately. I'm going to go to mono and you'll see the stereo light goes out. If I go mono, I'm talking over this so I don't get any copyright. Mono, stereo, so that's working correctly. Spin on to the next channel. It's a real pain in the arse, this copyright protection thing, because you can't do anything for more than about 2 seconds before they try and get a copyright on you. I'll show you the other annotations here. Trying to get it so you can see. So we got a selection here for wide and stereo IF bandwidth, which gives you a better selectivity and more rejection of adjacent channel interference. We've got a blend level, high and low blend, which is basically narrows down the I don't know what it exactly does. It does something to do with the IF, and it reduces the stereo separation and gives you better rejection against noise and hiss. This is the RDS button. Unfortunately, this RDS option isn't fitted with this tuner, but and then it's got various inputs where you can actually store the data on the tuner, and you know, you can actually enter display information. So if you've got a preset, so if we go to station and preset, preset 1, enter. This is BBC Radio 4, and you can manually enter your annotations on here. So that's fine. It doesn't. I don't really use RDS anyway. And we've got a display change button here that tells you, you know, different information. Seems to work really well, and that's all it was. Someone had been messing around with all the internal parts, all the power supply decoupling and things. We've got a shorty capacitor, a couple of blown fuses, and basically a bit of a tidy up, and got quite a big improvement off the RF front end with a bit of tuning up. I've got quite a good improvement in sensitivity. So thanks very much for watching. This is a lovely tuner. I've really enjoyed actually working on this tuner. At one point I thought, you know, I'm never going to be able to get it repaired because I can't get any manuals or any information, but as you know, I uploaded a couple of live videos, and a lot of my friends out there and a lot of people who can speak German translated the information for me, and it made it possible for me to sort of go through and get the alignment correct and set the RDS up. And obviously, once I set the RDS up, set up the discriminator, and once I realised the discriminator was in line, I soon sussed out that this display was the problem, and we fixed that. So it's just been a bit of a debug really on this tuner, but thanks very much for watching, and more to come. Okay, back together, and in the desperate attempt to sort of demonstrate this tuner for its fidelity, I know you won't pick up anything on the microphones. I'm playing an audio track from my CD player, and that's fed into the stereo Panasonic modulator, that's then fed into the Marconi generator, and we can generate a stereo signal with the obviously the modulation, because it's generating the 38 kilohertz to split this left and right channels. So we're feeding the signal into the tuner via just that dummy aerial rubber duck, or whatever you want to call it, and you can have a listen to it and see what it sounds like. And it sounds fantastic actually. It's got a good bass heavy, sort of not bass heavy, but a good weighty bass sound to it. Sounds really nice tuner actually. So I think I'll probably use this at home. Yeah, as I say, very enjoyable repair. Thanks for your help in translation, and more to come.